Okay, again, we are solving quadratics. So far, we have learned how to solve quadratics by taking the square root, by factoring, and today we're going to talk about using the quadratic formula. This is most useful for quadratics where the first term is not equal to 1, because otherwise you could probably factor it. But what's useful about this is it always works. One of the bad things about this is it's very tedious. It's not hard, but you really have to pay attention to your negative signs and the numbers. You can't do this while kind of focused on something else and get the correct answer usually. So the first step is we're going to get this problem into standard form. Some of them will already start out looking like this, but if it doesn't, like our example, we have to move the 12 over to this side so that all of the terms are on the left side and it's equal to 0. So I'll move the 12 over by subtracting it. Now it's in standard form. I'm going to find the a, b, and c. A is talking about the number in front of x squared. So the number in front is 2. A is 2. B is the number in front of x. You include the negative, so it's negative 5. And c is the last number here, negative 12. Oh, you can't see, sorry. Okay. Now we are going to use the quadratic formula. So let me rewrite the quadratic formula here. It's x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. We're going to replace these letters with the numbers that they represent. So let's rewrite this. Negative b. B is negative 5 plus or minus the square root of b, negative 5, squared minus 4 times a times c. A is 2 and c is negative 12. All divided by 2 times a. A is 2. So in this step, I've just replaced A, B, and C in the formula with the numbers that they represent. Now we're going to start simplifying, which is our fourth step. So a minus negative, like here, is positive. Oh, blue. It's positive 5 plus or minus the square root. Negative 5 squared is positive 25. I like to count my negatives up first. You might remember doing this yesterday with the discriminant. I have a negative here and a negative here. I have an even amount of negatives. An even amount means they will cancel out and I will be adding. Now I can just focus on the numbers. So 4 times 2 is 8, and 8 times 12 is 96. Of course, if that was confusing to you, you could ask me in class right now, or you could also try negative 4 times 2 is negative 8, and negative 8 times negative 12 is positive 96. So that's why there's a plus sign here, because these three numbers multiplied is positive 96. Okay, back to simplifying. All divided by 2 times 2, which is 4. Now I need to add these two numbers together. So 5 plus or minus the square root. 25 plus 96 is 121 divided by 4. 121 is a perfect square number. The square root of 121 is 11. So 5 plus or minus 11 divided by 4. This is again right here a time that you will need to remember these numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. These are your perfect square numbers. So if under the square root you have one of these numbers, it means it's going to simplify into a whole number. Okay, moving on. So this is two things really. It's 5 plus 11 over 4 and 5 minus 11 over 4. 5 plus 11 is 16 divided by 4, and 16 divided by 4 is 4. Now let's do the other side. 5 minus 11 is negative 6 divided by 4. Now this doesn't end up being a whole number, but we can reduce this. I know, let me kind of scooch over here. I know that 6 is 3 times 2, and I know that 4 is 2 times 2. You can reduce the common terms up here, and this will be the reduced fraction. So negative 3 over 2 is the other answer. So I found my two answers. They are x is equal to 4 and x is equal to negative 3 divided by 2, or negative 3 halves.